Hello, I'm Channa Bankapur. I'm going to discuss my solution to the LeetCode problem, linked list random node. It's today's daily challenge in LeetCode. The problem definition is we are given a single linked list and we need to return the value of a random node in that. And random here is uniform probability, right? Uh, Clearly, this needs a randomized algorithm because for the same linked list, every time we may return a different node. Uh, yeah, essentially a random node. So that's why a randomized algorithm is essentially here. Or in general, randomized algorithms use some kind of an element of randomness in their algorithm, so that the output is either different every time or it could take different time, right? That's what generally a randomized algorithm is. They are used for different purposes, but here it is very straightforward. Probably this is the simplest randomized algorithm. So we have a linked list of nodes. What we can do is, if there are n nodes in that, we can put them in an array of n nodes, and then which is going to be from 0 to n minus 1, n being the number of nodes. And every time when they ask for get random function here, so we can generate a random number, say k, and k can always be in the range of 0 to n minus 1. So you can generate any random number and then take mod n, that is going to be in 0 to n minus 1. So this is roughly with uniform probability of 0 to n minus 1 values. And you can just access the kth value in the array, and that's going to be the random, right? So this works pretty fast, but in the constructor, we need to create a new array. So this is going to take big of n time in the constructor level, and big of n space also, because we are using another array in this case. But get random is constant time, because getting a random number, a pseudo random number is going to take constant time, and then we just have to access the kth element in that, which is the reason we are using array is it's going to be a random access in the array, and that's why um, this is going to be big of one time for get random, right? So this is going to take big of one time. All right, let's see how to do it. They're also asking a follow-up question here. Can we do it, if it is extremely large, can we do it without actually taking extra space, right? In that case, maybe we should not be using an array there. So we can use the list, but in the constructor, what we can do is you can find the length of the list, and this length of the list is going to take big of n time, but no extra space, or no more than constant extra space. But in get random method, uh, we are going to generate the same random number k, which is in the range of 0 to n minus 1, but we cannot access, we don't have random access on the linked list. So we are going to linearly go over each of them, and then as in find the kth elements essentially in the linked list. That's going to take linear time. So this is the trade-off probably we should do. If we take constant space, we are going to need big of n time every time we call the get random method. By the way, list does not change. So in the first method, once we process the array, we don't have to change anything, right? And it's going to take constant time every time they call get random method. All right, so let me show you the code for both the versions I'm talking about. The first version is going to take big of an extra space. So here I have a vector here, and in the constructor, I'm going to basically copy the whole linked list into the array, or the vector. So, and then I initialize a seed for the random number generator. And in get random, I just get a random number rand. That's going to be a random integer. So I take mod of n, which is size of the array. That's going to result in a 0 to n minus 1 random number. And I'm going to access uh, you know the kth number, actually rth number here. All right, let me submit and show you. Right, it accepted. So the number of times they call get random is not going to affect so much, because it takes only constant time every time they call. But if I use another method here, where I take big of one extra space, so I'm not allocating anything, but I still have to find the length of the list. If I don't find the length of the list, I need to find length of the list in the get random every time. That's not bad asymptotically, because anyway it's going to take linear time to find the rth element in the list. So it's not really that bad, but because we are going to do the same job every time we call the get random, and list is not going to change anyway. So I find the length of the list here itself, right? Rest of the things are same. So we are going to find that rth element in the linked list. I'm going to return the value, right? So this should also work, but it's going to take little more time probably, because it depends on the number of times they call the get random method, right? So but otherwise both are acceptable. All right. So this, obviously this is the simplest randomized algorithm. So if you want to know more about it, search for randomized algorithms. There are more interesting and very useful algorithms. Um, it's a good topic to learn. All right. Otherwise, please like the video and subscribe to the channel. Keep solving a problem every day. Thanks for watching.